And you can't factor this the old standard way that we've done in the past, so we have to figure out some other way of doing it. So I will always give you some kind of a clue on what to do with these. So first thing that I would say is, so this would be part of the problem, I would say, is x minus 1 a factor of this? You are going to want to write this down because you're going to be doing similar problems to this. So is x minus 1 a factor? Now, rather than doing long division and having it take a year, what can I plug into y and see if it's a factor? 1. Okay, that's what we're going to do. We are going to plug 1 into y, so y of 1. So now it's going to be 1 to the 4th minus 3 times 1 to the 3rd plus 5 times 1 squared minus 27 times 1 minus 36. I really hope this works out. Okay, so this is going to be 1. This is 3. That's 5. That's 27. So 1 minus 2 is negative 2, plus 5 is 3, minus 27, minus 36. Clearly that's not going to be 0, so the answer for this one is going to be no. Okay, which does not help us at all, unfortunately. So what I'm going to do, oops, I don't want to do that. What I'm going to do is actually graph this because I don't remember my own answer key apparently. Sorry. If you graph it, it will also tell you the x-intercept, and you can do this. I'm literally telling you, you can do this on an actual test. X to the 4th minus 3x to the 3rd plus 5x squared minus 27x, oops, x minus 36. Okay, so it looks like there are 2 solutions here. We got one at 4 and one at negative 1. I'm stupid. I should have done x plus 1. That's why you have to write things down, Ozarka. What's wrong with you? Okay, so we got 2 solutions right there. We got x minus 1 and x equals 4 here. Or x is negative 1, I'm sorry, and positive 4. So I actually wanted this first one to come up with a yes, so that's kind of embarrassing. So what we're going to do now is I'm going to rewrite this and say, is x plus 1 a factor? Okay. So now what you would do is plug negative 1 into the y, or you can just use your calculator. If you did use your calculator, perfectly okay. I just did it. No, f of negative 1 is 0. Okay, let's just act like we used our calculator on this. I don't really know where the issue went. Oh, it's right here. I wrote 5 times negative 1. I forgot to make it negative 1 squared. That was it. Okay, well, rather than wasting time, I'm just going to say that this is equal to 0. So the answer for this one would be yes. Okay, so we are trying to write this. We're trying to find the solutions for this, and we're trying to find the factored form of this. Okay, so I'm going to write that over here. We're trying to find the solutions, and we're trying to find the factored form of this. Okay, well, we have 2 of the solutions already because I just graphed it and I showed you. It was x is equal to negative 1 and x is equal to 4. So we have 2 of the solutions. How many solutions should we have, though? Based on the power of this, the degree.
4.
4. Thank you, whoever said that. Appreciate that. So we are looking for 2 more solutions. Does anybody have any ideas on how to find those 2 other solutions here? Okay, this is where it involves long division. So now what we're going to do is we are going to take our y, or x to the 4th minus 3x cubed plus 5x squared minus 27x minus 36, and we're going to divide it by our 2 factors. Okay, if we divide it by our 2 factors, we're going to get a simpler equation to work with. It'll be quadratic, and then we can find the solutions to that quadratic. But we have to do long division first. So we have to divide it by x plus 1, and then whatever answer we get for that one, we have to divide it by x minus 4, because x minus 4 is part of is also a factor. All right, I'm going to move this further down so there's a lot of room. All right, don't wait for me. If you can start doing the long division on this, that would be great.
Yeah, I have a question.
Mm-hmm.
So, you always put a negative on the outside of the question.
Yep. Yep, you have to. You don't have to know why, because that's kind of complex, but
Okay.
you do. And since this is a factor, you have to be able to get a zero remainder. Otherwise, you did something wrong. Okay, remainder theorem. If it's a factor, there's no remainder. Is there a remainder, Scott? Uh-oh. Come on, man. Sweet, so there's no remainder. Okay, so we end up with that x to the third minus 4x squared plus 9x minus 36. And the only thing left to do now is to divide out that x plus 4. Or I'm sorry, x minus 4. Okay, x minus 4 is also a factor because when I graphed it, we got the solutions of -1 and 4. And if you remember, you can take the solutions and do the opposite sign. So it's x plus 1 and x minus 4 as your factors. So now what we're going to do is we are going to take our answer here, that x to the third minus 4x squared plus 9x minus 36, and we're going to divide this by x minus 4. First, are there any questions on what I did with this whole mess right here? Okay, let's work this one out now. Okay, this one we're going to divide by x minus 4. Okay, same thing as what we did before. Do some long division on this.
Wait, isn't that? Oh, wait, so we're taking the part on the top? Right?
Yep.
Okay.
Because then, if you notice, we lost one of the degrees. The degree was 4 before, and then it became 3. Now it's going to become 2, which means we can find those other 2 answers. Yeah, we're just dividing out those factors so we can get to that point. Let's see, this, cancel. Ooh, that's nice. This is way easier this time. Oh, wow. Okay, so that's it. Cool. All right, we still haven't found those other 2 solutions, so you do have to actually solve this out. So we found the other 2 factors, but we still have to solve this here. I will try to make your quiz just as easy as this right here, where you subtract 9 from both sides. You're left with, cancel, you're left with x squared is equal to -9. square root the top and the bottom, the left and the right, I mean. And you're left with x is equal to plus or minus, I'm going to pull the I out. So now it's just the square root of 9. Square root of 9 does simplify to 3. So your final solutions, the two solutions that we were missing, is positive 3i and negative 3i. All right, so then if we go back up, so if we go back up to the solutions here, now we're going to have all 4 solutions. So it's also x is equal to plus or minus 3i. Okay, so you have 2 here, 1 here, and then 1 here. So that's 4, which is what you should have based on that. And then the last thing is the factored form. This is the same thing as it's always been. You're just taking what you have and subtracting, like, do x minus whatever the root is. So it's going to be x minus negative 1 times x minus 4 times x minus 3i times x minus negative 3i. I ran out of room. Right, then times x minus negative 3i. Okay. If you do not want to do the minus negative, then just simplify it right away. Okay, so your final answer would be, if it's completely simplified, x plus 1, x minus 4, x minus 3i, x plus 3i. And if you notice the complex pairs right there, they always come in pairs like that, where it's good twin, evil twin like that. Okay. And that's the final answer. Okay. And this is the main thing that we're doing with 2.223 essentially. All of 2.2, if you notice though, we needed all of it to figure this out. Okay. Is x minus 1 a factor? No. We did a remainder theorem for that one. Okay. That was 222, remainder theorem. Then we did long division. That was 221. Now we're on 223. We're actually just doing long division twice and solving. Okay. That's, again, that's kind of how I designed it. So it all builds off itself and then, you know, ends up being where we're at right here. The only thing that's left is 224. With 224, all you're doing is you're given solutions and you have to go to factored form. So we have solutions to factored form. Imagine if I started with those kind of problems. Like I said, here's the solutions. What does the factored form look like? It looks like this. So you're just going backwards of what we just did.